How do quantum computers compute? Most people have seen the inside of a computer. Electronics, transistors, capacitors and all that. This is where all the zeros and ones are moved around and where all the operations are performed. This is where the computing happens. But how does it look like for quantum computers? Well, that depends massively on the type, so let's pick one. Ion trap quantum computers. An ion is just an electrically charged atom, and this is significant because charged particles can be controlled by electromagnetic fields. In fact, you can construct an electromagnetic trap that keeps ions inside at a fixed place. The qubits of such a quantum computer are simply two energy states of the trapped ions. All computations are based on logical operations called gates. You might know a few of those, like NOT, AND or XOR. From these basic elements alone, it is possible to construct any computation, no matter how complicated. In quantum computing, you can build anything you want out of just 1 and 2 qubit gates. The 1 qubit gates are very straightforward. We direct a laser beam with the correct frequency at an ion and can thus change its state between the 0 and the 1 qubit states. Yeah, the details are a bit more complicated. You have Rabi oscillations and stimulated Raman transitions, but conceptually, it's just shining a laser on an ion to switch its state. The 2 qubit gates are more interesting because you need some mechanism to get information from one ion to another. For this, we use that the ions not only have internal energy states, but also states of motion in the trap. The ions can either oscillate all together, in phase, or against each other, out of phase. And we can transfer the qubit state of one ion onto the motion state and then transfer the motion state to another ion. And this is the Cirac-Zoller gate, and I mention this because Professor Zoller is the one who taught me quantum mechanics at university. If you're interested in learning more about quantum gates, I've done an entire video on this and I will link it down here somewhere. Subscribe for more quantum computing.